those that are not here. So what we've got to do, this is two things we need to cover. We've covered them both before, but let's just sort of finalise it with some proper notes. So we either want to calculate probabilities of an event happening based on a normal distribution, okay, or we want to work out, given a probability, what the values will be. And we're going to use our calculators to do it. So we've got this situation. I've just made up some numbers. The numbers don't mean anything. I've not got any context for it. It's not math school or anything like that. Just saying I've got a normal distribution curve. I've got a mean of 68, whatever that represents. Not told you. I've got a standard deviation of 4.5. And what I'm asking for is, what is the probability that x, the value, will be between 60 and 78. So I've drawn on my normal distribution curve two lines, and this line here would represent the 60, okay, and this line would represent the 78. So we're looking for the probability. So that means we are looking for the area between them. What's the area of the curve? Now, because we're not dealing with whole values of standard deviation, it's not whole values of standard deviation, so we're going to have to use our calculator. So, does anyone remember stats, I think?
It was bars. It was second and then...
Yeah, so vars here, above it is distribution. So we're going to go to second and vars for distribution. That's the second one, normal CDF. Okay, press enter on that. So we just need to put our lower bound in is 60. Our upper bound is 78. The mean, we were told, is 68. And standard deviation is 5. We just do it. Press enter, and we get an answer of 0.949. So 0.949. So what's that as a probability then? So I've got 0.949 on the calculator, but as a probability I would be stating 95%. Okay, for 94.9%. So 3 significant figures that we were normally asked for. So that would suggest actually that my lines are in completely the wrong place, because really if it's 95% they're going to be more over here and the shading is going to be much wider. Okay, doesn't matter, I just showing roughly where it is either side. Okay. So that means this area would be 95%. That's what we mean by that. Any questions on that? On the calculator, when we started, if I go back to second vars, normal CDF, before in the lower bounds, the lower limit, it had -1, I think, e to the 99. Okay. Why does it have that? What does that mean? Do you remember? No? Well, if yeah, a very, very negative number. And what that is when we have a different situation where, sorry, just do another quick one. this problem that we just did here was between two particular values. But what if we had our normal distribution curve, okay, and it was just the probability that x is less than, same problem, let's do less than 52. So in this case, we'd have to put our line at 52, and then less than would be all this space. But this goes on, this line actually goes on forever, goes down to negative infinity. So we have to have a really, really small number. So if I just want to know less than a certain value, I can just put in that. But I think when we did it, it's not necessary to put that. I could have just put a really small number, which would have been, I guess if you put 0.000, just put a few in and put a 1, you get the same thing. Okay. So in this situation, if I put that lower bound in like that, upper bound of 52, I can then get that situation, which is a very, very small amount. So just checking your standard form knowledge. So I've got 1.886 e minus 4. So 1.886 e minus 4. What does that mean?
1.886 times to the negative 4.
Okay, so we've got 1.866 times 10 to the negative 4.
So
0.000 or 000. One more 0 or one more 0.
1.866.
Okay. What's that as the percentage?
0.01866%.
So that would be the probability here. 0.01866% would be the probability of it being less. Okay. All right. Any questions on that? No? Okay. Next one then. We now need to look at doing the opposite. So we're going to find value given the probability. Okay. So for instance, we'll take the same situation. We have mean is 68, standard deviation is 4.5. But what if we're told that the probability of x being greater than a value k is equal to 46%? What would that look like on our diagram?
What's in bracket P? That says
X is greater than K, and we're told this time that the value is 46%, but we're not told what the value is. But what would it look like on our diagram? So I can draw a line to represent K. Where would I draw it?
to the left.
To the left. So I went
If it's
X
less
is
than
greater than K
Oh, to the right.
is only 46%. Now, the mean represents what and what? 50%. So I'm going to have a line roughly around here, and I know that that would be K. Yeah. And then all this area above, okay, has to be So that's 46%. Right? So,
But if you start from 0 and go up, wouldn't 46 be less?
well, so that's the question, isn't it? So I'm going to solve this. So solve using inverse norm on the calculator. But what rule did I say inverse norm applies to the calculator?
Oh, they start from 0 and go up.
Yeah.
You can't see.
So inverse norm starts at this end and goes that way. And it will calculate. So if I do 46% but start it on here, it's actually going to stop it here instead and give me a k value that's below the mean. So I don't want that. So how do I actually get the 46% I want? So the calculator will calculate for me the other side. The calculator is going to do this region. Right? That's what the calculators will do. So, I do what? You should take away. Yeah. So what is it? The calculator won't give me the 46 above. So if I did 46, it would give me this value here, which I don't want. I need to go all the way up to k. So instead of working out 46%, what do I need to work out?
100 minus 46?
So this region would be 100 minus 46, which equals 54. So I need to work out 54%, not 46%. Because the calculator works left to right, and the GDC works left to right. So if I want greater than, I've got to interpret that value. So, if we look at our calculator, we've got second bars, this time inverse normal. How do I put the area in? If I want 54%, what do I write in? Very good, Alan. 0.54. The mean, I'm going to put in, still 168. Standard deviation still 4.5. Paste that in. And we are told that if that's right, the K value is 68 point, whatever it was, 45. 68.45. Okay, so only slightly past the mean, really small amount. Okay, that's our K value.
And then we just stick it into something.
No, we've got it. So basically then we can say that the probability that x is greater than 68.45 equals 46%.